Hey guys, today we're going to be going through some difficult A-level maths questions. Hope you enjoy. Here in this first question, we're given a function y equals x to the x, and we're told to find, by firstly taking logarithms, the turning point of the curve. Now, how do we find turning points? Well, all we need to do is differentiate the function, then set it equal to 0. So that's exactly what we're going to do. First of all, let's take logarithms because we're told to do that. So we have ln of y is equal to ln of x to the x. Now, immediately when you see this thing right here, remember your log rules. When you have a log raised to a power, you can just bring the power to the front. So this is equal to x lots of ln x. Now what we're going to do is differentiate. So as you can see, we are going to need to use implicit differentiation. So let's start off with the left-hand side first, as that's the easier bit. Remember, for implicit differentiation, you just differentiate like normal, but then stick a dy by dx to it. So this is going to differentiate to 1 over y, and then just stick the dy by dx on it. And this is equal to, now we're going to differentiate x ln x. So we have two functions right here, and we want to differentiate. So we're going to use the product rule. Now, to use the product rule, we multiply each term by the other term's derivative. So let's just differentiate each term. So x differentiates to 1, ln of x becomes 1 over x. And now that means using our product rule, we get 1 over x times x, so that is 1, plus ln of x times by 1, so ln of x. Now we want to get just dy by dx, so we're going to multiply the y to the other side. So we have dy by dx is equal to y lots of 1 plus ln x. Now we want everything in terms of x, obviously, so just replace y with x to the x. So this is what we're left with. And now we want to find the turning point, so obviously, like we said, we're going to set this equal to 0. Now we just have a product of two functions which are equal to 0. So to find the solutions, we just set each thing equal to 0. Let's start off with x to the x. Now, if we try and solve that equal to 0, well, notice this gets no solutions, because even looking at this graph, you can see it never intersects the line y equals 0. So this has no solutions for x greater than 0. So that's that part done. Now we're going to look at the other bracket, which is 1 plus ln of x is equal to 0. This does give us a solution because we get ln of x is equal to minus 1, and then just raise both sides to the power of e. So we get x is equal to e to the power of minus 1, and that's our final answer. Quick announcement, I offer online maths tutoring. If you're interested, just contact me through the WhatsApp shown on the screen. Here in this final question, we're first given a sketch of this modulus graph, and then we are told to sketch the graph with equation k minus the graph we're given the equation of. Now, for a question like this, we could just try and draw this graph all by itself. However, a smarter way of doing this would be to try and use the graph we're already given the sketch of, which is right here. So what we're going to do is we're going to see how you go from this graph to this graph, because all it needs is a few transformations. So let's see what those transformations are. Well, first of all, if I just go up here and just redraw this graph right here, we're going to look at the transformations one by one. First of all, we can see we have a minus in front of this. So let's draw the graph of minus 2x minus 3k. So what this is doing is it's just reflecting it in the x-axis. So this graph is going to look like this. It's just flipped upside down, basically. Now let's try and get to our full graph, which means we just need to add this k on. So if we add k, then what we are essentially doing is we're translating this blue graph k units upwards. So our final graph is going to look something like this. Now I'm just going to draw it properly. So our translated graph is going to look something like this. So we'll just write this is f of x, and this is the x-axis. Now all we need to do is just mark the maximum point and also where it cuts the coordinate axis. So the easiest point is first going to be doing where it cuts the coordinate axis, this one right here. So the x coordinate is going to be 0, obviously, And to get the y coordinate, well, we just sub in 0 into this equation. So what we're going to be left with is k minus the modulus of minus 3k. So that is just k minus 3k, so that's minus 2k. So that's that coordinate right there. Now we're going to try and find these 2 points, where it cuts the x-axis. The way we're going to do that is by just setting each of these blue lines equal to 0. So this first line right here is going to have the equation k minus 2x minus 3k. And the reason for that is because if you remember a modulus graph, it has 2 sections. So if we look at the graph we're given, this graph has equation 2x minus 3k, but then this line will have the negative of that. So it's going to be the negative of this. So that is 3k minus 2x. You can tell which graph is which by just looking at the gradient. This is negative 2, so it has to be this one. This one's positive 2, so it has to be this one. So if we just simplify this equation, it's minus 2x plus 4k. If we simplify this equation, now this left blue equation is just going to be the negative of this. So instead of k minus that, it's going to be k plus that. So we're going to have 2x and then k plus 3k. So that's going to be 2x. Sorry, no, it's going to be k minus 3k. So 2x minus 2k. And now what we're going to do is just set each of those things equal to 0. So if we set minus 2x plus 4 equals to 0, we get x is equal to 2. So this is 2, 0. If we set that left thing equal to 0, we get x equals 1. So that is 1, 0. We're just doing this equal to 0. And now we just need to mark the maximum point coordinate. And the way we're going to do that is by looking at our original equation. So let's think about what's happened to our maximum point going from this equation to our blue equation. Well, we actually drew it right here. So first of all, going to the blue equation, the maximum point has not changed. But then what we did was we translated it upwards by k units. So all that's happened to our max point is it's moved up by k points. So the x coordinate has stayed the same, but the y coordinate is now k. So it's something k. Let's find what the x coordinate is. Well, all we need to do that is set one of these lines equal to 0. So if we set the left one equal to 0, for example, we get this. So we get x is equal to 3k over 2. So that's our max point. It's 3k over 2, and then the y coordinate is just k. Here for part B of this question, we're told to solve the inequality in terms of k, where this, which is just the graph we've drawn, f of x, is greater than x minus k. So the way we're going to do this is by first drawing this line x minus k on our graph here to get an idea of what we're actually solving. So the line x minus k, well, it's going to start here because we're drawing this y equals x minus k. So the y-intercept is minus k, and it's going to sort of go like this. And now if we think about what we're actually trying to solve, what we're saying is f of x is greater than this line x minus k. So this is saying we want to find the set of values where this equation is above this equation. So if we look at the graph, where is our blue line above the red line? Well, it's in between these values. So it's in between the 2 points where the lines intersect. So we just got to find those 2 intersection points, and then that's our range of values. So if we first try and find this one, well, what 2 lines are intersecting? We have x minus k, that's obviously intersecting because it's the red line, and then we have this left blue line, so it's 2x minus 2k. And we just solve this, which will give us x is equal to k. So that's our first value. And now what we're going to do is find the second intersection point, which is going to be minus 2x plus 4k is equal to x minus k, because those are the 2 lines that are intersecting. if we solve this, then we're going to get x is equal to 5k over 3. So these are our two values. So we just got to write it in set notation, so for set notation, remember you do like these curly brackets, then you do a x and then a colon, which is saying we want the set of x values, and then we write what values it can take between. So the smallest value it can be is k, and the largest value x can be is 5k over 3, because we've just written this highlighted interval now, and that's our final answer. In this final part of the question, we're told to find in terms of k the coordinates of the minimum point of the graph with equation y is equal to 3 minus 5f over half x. So the way we're going to do that is we're going to first look at our original graph f of x and then apply the transformations which will take us to the equation y. So we're going to do the transformations one by one. Now when you have combined transformations, a good rule is to first work from inside f of x and then slowly move out step by step. So basically we're going to apply all the transformations to our maximum point, and this will be the coordinates of the minimum point of this graph. So what's the first transformation? Well, we need to go from f of x to f of a half x. And let's see what happens to the coordinates between those points. Well, we're just affecting the x value. So k is still the y coordinate. And what happens to this? Well, this is saying a translation of scale factor 2 in the x-axis. So what's going to happen is all our x values double. So our 3k over 2 is just going to become 3k. Now we're going to apply our next transformation. So that is minus 5 lots of f of a half x. Now what is minus 5 lots doing? Well, what is happening here is we're multiplying our curve by minus 5. All the y values are getting multiplied by minus 5. So the x stays the same, but the y becomes minus 5k. And then finally, all we do is we just translate this up by 3. So if we translate this equation up by 3, the x coordinate is going to stay the same. However, the y is going to be raised by 3. So our final answer is 3k for the x coordinate and then 3 minus 5k for the y coordinate.